Welcome to This Explainer. Today, we're unpacking a really fascinating evolution in how AI agents actually operate. If you've been following the AI space, you know that how we communicate with these machines is just constantly shifting. Right now, we're moving away from basic data connectors to these incredibly intelligent, memory-efficient systems called skills. It's a fundamental shift in how we instruct AI, and we're going to break down exactly how this transition is happening step by step. To kick things off, I want you to think about this bold statement. The hottest programming language is English. Honestly, we're going to fully grasp the weight of that quote by the end of our journey today, as we explore how telling a machine what to do has drastically changed. We're no longer solely relying on crazy complex syntax to build powerful tools. It's all about natural language now. All right, part one, connecting AI to the world. So let's rewind about 18 months to a massive breakthrough. The Model Context Protocol, or MCP. This thing basically acts as a vital bridge. Because suddenly, your AI wasn't just this isolated chatbot sitting on an island, right? It actually had a standardized protocol to talk to the entire outside world. Just using natural language, your language model could suddenly reach out, talk to APIs, and literally access local file systems. And honestly, MCP is still a massive, fundamental force today. Anytime you see a connector in your favorite chat app that grants access to different tools or external data, well, it's highly likely it's being powered underneath by MCP. It essentially became the default, invisible infrastructure for connecting our conversational models to real-world tasks. Which brings us to part two, the context bloat problem. But here's the catch. As we started equipping our AI with more and more capabilities through MCP, a pretty major bottleneck popped up. The downside is really in how MCP defines these tools. Those definitions can easily run hundreds of lines long. So just imagine forcing your AI to simultaneously process all those irrelevant instructions for, say, 20 different tools just to have a single, simple conversation with you. This perfectly illustrates what the industry calls context bloat. Think about the crazy contrast between a super simple user request and this massive wall of loaded tool definitions. Managing the model's memory becomes incredibly tricky, mainly because MCP just lacks a built-in method to selectively compress or choose what to load when the agent starts up. It's basically an all-or-nothing approach, and man, it just eats up memory. So let's look at the solution in part three, enter the skills framework. To fix this massive inefficiency, developers created the skills framework. Now, the absolutely crucial thing to understand here is that skills did not replace MCP. We aren't just tossing the old protocol in the trash. Instead, skills arrived as a complementary system to better manage all these interactions. It really came from the realization that, a lot of the time, users don't even need an external tool or a complex API. What they actually need is a way to capture a prompt, save it, and reuse it efficiently. Get this, 80% of the time when we talk about a skill, we're literally just talking about a saved prompt. For most folks, you can picture this as a basic markdown or text file housing a prompt that you want to use over and over again. It's easily stored, easily retrieved, and you don't have to drag in an entire heavy software library to do it. But you know, skills can also go way deeper than just a simple text prompt. They're actually defined in this really elegant three-part structure. Step one is the front matter, which is basically a summary telling the model exactly what the skill does and when to use it. Step two is the body, and that contains your human-readable English instructions. And finally, step three, which is optional, is linked files. And wow, this is an absolute superpower because you can link to specific scripts or command line instructions if you want that skill to run deterministically. Now, the real secret sauce of this whole framework is a concept called progressive disclosure. When your AI agent boots up, it only looks at step one, that front matter. This brief summary lets the agent keep an internal registry of all its capabilities without getting totally overwhelmed. It actually delays loading those detailed, human-readable instructions until the AI decides, hey, this skill is actually necessary for the task at hand. When you compare the two directly, it's honestly night and day. MCP forces the system to load every single definition right at startup, which is what creates all that context bloat. But this tiered approach with skills, where it loads the front matter first and only pulls the heavy instructions on demand, leads to a massively more efficient use of memory. It perfectly solves the context bloat problem because it's just fundamentally more compressible. Moving on to part four, coding in plain English. This whole evolution brings us to what might be the most empowering aspect of all this, the democratization of programming. Since skills are primarily just written in English inside easily shareable markdown files, teams can effortlessly capture their core business logic. You can literally write a skill, iterate on it, dial it in perfectly, and then just share that file over to your coworker. You don't need a computer science degree anymore. You just need to know how to clearly write out instructions. It totally empowers non-developers and makes your entire team move so much faster. Which brings us right back to our opening thought. It's just absolutely wild how much utility you can get out from just telling a machine like, this is what I want you to do. This shift has taken simple, natural language discourse and turned it from a quirky chatbot novelty into a highly rigorous, incredibly powerful tool for complex system control. And finally, part 5, the perfect AI partnership. To wrap this explainer up, let's look at how these two distinct systems synthesize, because they definitely aren't mutually exclusive. Oftentimes, you're going to use both of them right in tandem. The best way to think about it is this. Your English written skills act as the map. They specifically instruct the agent on exactly how to effectively navigate and use the API tools that are provided via the MCP, which acts as the essential bridge. This industry is just moving incredibly fast. And as we keep iterating and learning through each generation of these practices, going from massive, clunky context loads to this elegant, progressive disclosure, it truly feels like a magical time to be alive. We are literally shaping how human-centric technology operates in real time. So I'm going to leave you with this final thought to ponder. As you think about how you might build or interact with your own agents using these incredible new frameworks, ask yourself, if plain English really is the new code, what will you teach your AI to do tomorrow? Thanks so much for joining me for this explainer. I hope it gave you a crystal clear look at the powerful synergy between MCP and the skills framework.